Okay, the next thing that I want to cover with you is that if you look at page 20, lines in linear functions, we claimed in our introduction that the graph of a linear function, f of x is equal to ax is equal to ax plus b is a line. Our discussion shows that it is the line with a slope of a and a y-intercept of b. That's because that's in that format of y is equal to mx plus b. So it's very similar to that formula. They're just writing it as a function. For example, the graph of, so they tell you, if I give you the graph of f of x is equal to 4x plus 3. That's a graph of a line. What is the y-intercept? 3. What is the slope? 4. Non-vertical lines has a slope of m and a y-intercept of b, and so is the graph of the linear function f of x. Okay. So other things that can happen. What if I just told you f of x is equal to 2x? What does that mean? What's the slope? The slope is 2 and the y-intercept is 0. But what if I tell you f of x is equal to 7? What type of a straight line? 0 slope, right? It has a 0 slope. So this actually happens to be a horizontal line that crosses the y-axis at 7. So that point right, that part of your graph is at 7. So it's the horizontal line. All right, here's the example. Look in your book at example E. Find the formula for the linear function that satisfies, oh, now we got this important information. What does all this mean? This looks really, really confusing. It says f of -1 is equal to 4, and f of 3 is equal to 12. Then calculate f of 2. They want to know what f of 2 is. And all of this, I have to come up with an equation for a line. If I knew an equation for a line, I could put 2 in and find it. But I don't know the equation of a line. But what do you know about this right here? What's this telling you? A point. What is that coordinate point? -1, 4. When x is -1, f of x, which means the same thing as y, which means the same thing as output, which means the same thing as dependent. Remember that sheet that we started to fill out? My y value is 4. It's a coordinate point right there. I have another coordinate point. What is it? 312. I have 2 points. How can I come up with a function, which means an equation for a line? I could do the 2 points, but remember how that had that whole messy thing in it when we talked about the 2 points, and that was that slope part? So let's find the slope separate. So then I have a point and a slope. So what is the slope? My slope is equal to the change in y over the change in x. What's your first y value? 4 minus 12 over, which gives you negative, and my slope is 2. So what's an equation? Y minus 4 will work, equals 2 times minus -1, which means +1. See how I do the minus -1? There is, what did they ask for? Just a minute. Find the formula for the linear function. Okay, I found a formula. Then it says calculate f of 2. It didn't tell me what format to put it in, did they? However, what were all of these over here? Like an f of x. It's like an f of x. And f of x means the same thing as y. So if I wanted a function for it, I would solve for y. So I'm going to have y minus 4 equals 2x plus 2. And then I'm going to add 4. So y is equal to 2x plus 6. And you might see it in this format. That's an equation. But as functional notation is going to say f of x is equal to 2x plus 6. All of these mean the same thing. It's just which form to put it in. And that's something you're going to have to pay attention to when you show up to class at college and you notice what the professor's doing. And a solutions manual may show it in this format, and in the book they're going to show it in this format, and the teacher talks about it in that format. And you got to realize they're all the same. You have to have that good solid foundation to recognize they're the same. So now the last step, I've come up with my equation. It's any one of these. Probably not worrying about that one right there, but it's okay. All right, so f of 2, what is f of 2? You put it in and you get 10. 2 times 2 is 4 plus 6 is 10. So f of 2 is 10. But it's recognizing that f of -1 is 4 is actually telling you a coordinate point. Then the last thing that they give you is they just discuss in those last little paragraphs there on page 20, 2 simple examples of slopes. In building a house, a carpenter may say he is putting up a roof with a 7/12 pitch. 7/12 pitch is actually talking about slope, the pitch of a roof. Nobody's in construction. You're in what? What do you? Oh, computer design. What he means is that the roof will rise 7 feet with a run of 12 feet. So they talk about a pitch of 7 to 12. You're going to rise 7 and run 12, and that's going to give you the slope of a roof. Guaranteed, I don't know, you may not want 12 and 7. Ooh, that was really veered off there, sorry. But I mean, think about how you want that pitch to be. You talk about pitch, and it's going to happen with wheelchair ramp. There's certain codes of how steep a wheelchair ramp should be. You don't want them zooming down it, and you want them to be able to get up it. So it has to be at a certain grade. That grade, which you could talk about, which you talk about roads in a mountain. That's that next example it says there. In the mountains, one often sees a road sign like the one in figure 25, indicating that it is called the grade. What is called the grade? A grade of 12% is simply a slope of 12 to 100. Of course, you are driving downhill. The slope is really -12 to 100. You go down 12 when you go over 100 instead of going up 12 over 100. So positive and negative grades, a wheelchair ramp, a pitch of a roof, that's where you're going to be dealing with those types of slopes. I don't know if you could think of another example. There you go. Calculate the grade of the road so you can know how, or of the course in various spots. Now the next thing though, what you're going to use is the next lesson deals with story problems of linear equations. So if you were to glance ahead, which you don't have it in your possession, 26 story problems that's going to deal with this information. So make sure you get this down. See, you said you were already maybe at 20, and there's 38 questions. So you're doing good for this lesson. Questions?